Okay, good afternoon, ladies and gentlemen. So our objective for today is that students will be able to express numbers written in scientific notation in standard form. So those might be some words that you're not familiar with, but after today's lesson, the idea is that you will be familiar with them, right? Also, for today's Zoom meeting, you are going to need a password, which is going to be hidden somewhere in this video, right? If you watch the video, it will be extremely obvious what the password is, but I just want to make sure that people are actually watching it so that they are learning and not coming to the Zoom session with questions that were answered here. So if you remember yesterday, we were talking about cutting up pieces of paper, making ballots, right? If you were paying attention and you did it correctly, you should actually notice that every time we cut the paper in half, the amount of ballots doubled, all right? And you yesterday should have made two things. One, a table, two, a graph to represent that relationship, right? Now, looking at these two, especially looking at the graph, it's very easy to see that this cannot be a linear relationship because this graph has a curve that's going slightly upward like this, right? Whenever we saw something that was linear, it was always a straight line. This here is obviously not a straight line, so it is not linear. It's something else entirely, all right? What this here is actually called is it is an exponential relationship. And we're going to explain what that means throughout this unit, all right? So first, to try to understand why it's called an exponential relationship, let's look at this pattern here, right? We saw every time the number of cuts doubled the number of ballots, right? So for one cut, we had 2 ballots. When we made our second cut, we doubled this. So to get to 4, that was actually like saying 2 times 2, right? I multiplied the previous thing by 2. Now, again, going to 3 cuts, we doubled what we had before. So we did 4 times 2, or this, what I had before, times 2, right? 2 times 2 times 2 gives you 8. And again, for 16, we doubled the previous result. So 2 times 2 times 2, this here is equal to 8, multiplied by 2. So let's just add some parentheses to make this a little bit easier to see, right? This here is what I had before, times 2. This here is what we had before, times 2. So each time we're adding one more 2 onto there, again with the 32. 2 times 2 times 2 times 2. So we're starting off with 4 2's here, multiplied by 2 because we did 16 times 2. So this pattern keeps on doubling, right? But now you're going to say, Mr. Correa, I'm not going to sit down and write out 10 2's, right? Nobody got time for that. So what we actually have in math that you should be familiar with from when we studied volume is we have exponents, right? Remember, exponents tell us how many times I'm multiplying something. So another way that I could rewrite this here, 2 times 2, is I could say that's 2 squared, or 2 to the second power. Similarly, 2 times 2 times 2, that's equal to 2 to the third power, or 2 cubed. This one would be 2 to the 4th power because I have 4 2's. This one would be 2 to the 5th power because I have 5 2's. And the first one here, right, I only have 1 2. Another way that I could write that first one is 2 to the 1st power. So hopefully at this point, you're starting to recognize a pattern, right? What I see over here, I see the number of cuts was 1. This is 2 to the 1st power. Over here, I see the number of cuts was 5. That was 2 to the 5th power. So based on the number of cuts that we have, that's telling us how many times you need to multiply 2 to get your result. So instead of having to write all these 2's out, right? Let's say I'm talking about 2 to the 8th power. The exponent is 8. So what's going to end up happening is that would look like 2 raised to the 8th power. And if you check that with a calculator, you're going to see that that is equal to, in fact, 256. Likewise, 2 to the 10th power is what we're going to get for 10 cuts. So we don't have to keep going in order now that we recognize this pattern here, right? I could say, for example, what if I went down to 17 cuts? That's going to be 2 to the 17th power, right? And because of that pattern, that leads into the equation that represents this here it's going to be y is equal to 2 to the x. That's when y is represented by the number of ballots, x is represented by the number of cuts, right? If this isn't making too much sense yet, don't worry about it. So we're going to spend a lot of time looking at these in the future, okay? But main thing to realize is look where our x is. Our x is the exponent, so that is why this is called an exponential relationship, because we have x as an exponent there. Okay, again, don't focus too much on the equation. I just wanted to explain why this is. If it's not making 100% sense yet, don't worry, that's not our goal for today, all right? So next page, right? What we're gonna do is we're just gonna practice with that equation a little bit. So over here, right, we have our equation. Y equals 2 to the power of x. So if you wanna know the number of ballots, which is y, you take 2 and you raise that to the power of however many cuts you did. So if I wanted to figure out, for example, how many ballots would there be after 6 cuts, I know that that's gonna be y equals 2 to the 6th power. That's gonna tell me how many ballots you would have after 6 cuts, right? Now, I can say, okay, that's 2 times 2 times 2 times 2 times 2, 6 times, or you can put it into your calculator, 2 raised to the 6th power. You're gonna see that that should give you, 64 ballots. Similarly, over here, 11 cuts. To figure that out, I'm gonna say that's y equals 2 to the 11th power. And again, you put that into your calculator. If you click this link here, that's gonna bring you over to that scientific calculator that I shared with you a couple of days ago, right? We're gonna see that 2 to the 11th power should give us 2,048 ballots. Okay, so at this point, you are going to use this scientific calculator to figure out how many ballots you're gonna have after 15 cuts, 25 cuts, 30 cuts, 40 cuts, right? Write down what you see on your calculator in the boxes provided, right? You can pause the video, work on that right now. Okay, so now that you got your answers here, you may have started to notice some strange things going on, all right? 2 to the 40th power ends up being a very large number, right? So I'm not sure if you're familiar with this guy here. This is the crocodile hunter. He was famous. He basically went into the wild, looked at crocodiles, wild animals. He's famous for saying, crikey, like that's a big gator. So our password for today's Zoom session is CROC, lowercase, C-R-O-C. Again, that is the Zoom password for today, C-R-O-C, CROC for crocodile hunter. Okay, now on your calculator, again, these numbers are getting extremely big, so your calculator only has so many numbers on the screen, right? It's only able to display numbers that are up to a certain size. So we have something called scientific notation that is used to represent extremely large and extremely small numbers. So depending on what type of calculator that you use, you might have seen different things, right? If you're using a calculator like we used to have in school, those scientific ones, you would see something that looks like this, 1.0995, 11628 times 10 to the power of 12, right? If you use the Desmos scientific calculator link that I had provided for you, you saw something like this, right? Basically the same thing, right? Other calculators, it might say something like, say, 1.099, 51163, E12, right? That means like exponent 12, but they all mean the same thing. Again, this here is referred to scientific notation, and it is used to represent numbers that are extremely large, but also numbers that are extremely small, okay? So to try to figure out what this means, it's actually telling us what to do here. It's saying that I have this decimal here, I need to multiply it by 10 to the power of 12, right? That's actually something that's very easy to do, but before we do that, I just wanted to step back for a second and just remind you guys about how we multiply powers of 10. So, for example, if we have 3.141 times 10, you can put it in your calculator, you'll see that that gives you 31.41, right? Similarly, if I did 3.141 times 100, put that into my calculator. I'm gonna see that's 314.1, right? So what's actually happening here, right? A shortcut that you may have learned in prior grades is that based on how many zeros we have here, I have 1 0, I need to move my decimal point 1 space over to the right because the number is getting bigger. So I'm going from 3 to 31. Same thing over here. Now I have 2 decimal places, so I need to move my decimal point over 1, 2 times from here to here. So 314.1. Now, next example, I have 1,000. So 3.141, I need to move this over 3 times. So I need to move it over 1, 2, 3. So in this case here, I would get 3,141. I could say point, remember, you can always put a 0 at the end, or I could just say 3,141. Now, 10 to the 4th, right? What 10 to the 4th is equal to is a 1, 0, a 1 with 4 zeros after it, right? So I have 4 zeros. This 4 here tells me how many zeros I'm gonna have. So what I need to do in this case here is move this decimal point over 4 times. But I'm gonna say 1, 2, 3, and I ran out of places to move it, okay? So at this point, I'm basically gonna add a 0 for every other time that I have. So this was 1, 2, 3, 4 jumps. I end up having to add an extra 0 in for however many jumps I made where I didn't have a place. So this here would be 3, 1, 4, 1, 0. Now what I like to do is I write all the numbers first, and then I work from the right-hand side to figure out where my commas go. So 1, 2, 3 digits. That tells me that's 31,410, okay? If this looks confusing, just try rewinding the video, play it back again, follow along yourself, okay? Now, we're gonna use that trick to figure out what this is equal to here, right? So I've got 10 to the power of 12. My decimal point is here. I need to move my decimal point to the right 12 times. So I go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So in essence, a little hard to see here, I'm gonna have to add in 1, 2, 3, 4 zeros here, okay? For each of these jumps that I made afterwards. So I'm gonna write 1, 0, 9, 9, 5, 1, 1, 6, 3, and 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros, and I could say 0.0 if I want. I don't need it to, right? Now, last thing I'm gonna do is I'm gonna count from the right. 1, 2, 3, comma. 1, 2, 3, comma. 1, 2, 3, comma. 1, 2, 3, comma. Okay, so that's it. Now, if I want to try to figure out what this number is, I'd say, okay, so thousands start here, millions start here, billions, trillions. So this would be 1,099,511,630,000. Again, that number just takes a long time to read out, right? So instead of saying that whole thing, we have this number here, which although it might look more confusing, is actually a lot simpler to express that extremely large number, all right? So I'm gonna go over 2 more examples with you. Actually, I think 1 more example, and then you're gonna practice this yourself, okay? So the examples that we're gonna do are a little bit smaller, right? They should be a little bit easier to work with, and then we're gonna practice this more throughout the unit, okay? So our example here is 3.14159, which is approximately pi, multiplied by 10 to the 4th. Remember, this 4 tells me I need to move to the right 4 times. So my decimal point is here, 1, 2, 3, 4 times. So it's between the 5 and the 9. So my number is gonna be 31415.9. right? Again, let's see where my commas go. 1, 2, 3. So 31,415.9. In that case, I did not have to add any extra zeros, right? Some of these examples you will, some of them you will not. So the idea is I want you to practice this. Again, this here is the objective for today. So if you understand this section, that means that you have met the objective. You were able to convert numbers that were written in scientific notation to what we call standard form, right? This number here, again, is written in standard form. This number here is written in scientific notation, right? So practice that. If you have any questions, I will be on the Zoom session later on. And then once you're done with that, I would like you to give this section a go, right? I didn't go over it, but what do you think will happen when we multiply by a negative exponent, right? I'm just gonna tell you that means that we are dealing with a very small number, and I want you to try to figure out, maybe you could research it yourself, how are you gonna express that number in standard form, okay? So that's it for today. I will see you on the Zoom session. Don't forget what the password was, okay? You're gonna need that password to enter the session. Good luck.